Okay, let's start. So today we will discuss the assignment 6 for the course calculus of one variable from the previous one. Okay, so what is the first question? So you have to find the value of the improper integral integration 1 to infinity log x by x square, right? So this is, you have to find this integral 1 to infinity ln x by x square dx. So this is improper integral because limit is from 1 to infinity, right? So how to do this? So means you have to write it as limit some capital M tends to infinity limits 1 to m ln x by x square dx, right? Now this is a Riemann integral, you can do it because there is no singularity right now. So just put this change of variable ln x equals to z, means it will be 1 by x dx, it is dz. So if you put it here, you will get limit m tends to infinity 1 to m ln x will be z and 1 by x dx will be dz, and remaining 1 by x we can write from here, we will get x equals to e to the power z, right? So what will be the value then? So it will be z e to the power minus z, right? So it will be z e to the power minus z dz. Okay. So now you can do it by integration by parts. So this is by, we can integrate this by integration by parts. So what happen if you do it? So take this as a first function. Okay. So we are discussing the first question. This is the first question. You have to find the improper integral, this 1 to infinity ln x by x square dx. So you write it as limit m tends to infinity integral 1 to m ln x by x square dx. Now we make the change of variable ln x equals to z. So it will be 1 by x dx equals to dz. So I am putting it here, ln x will be z and 1 by x dx will be dz, and remaining 1 by x will be e to the power minus z, right? So now you have to do this integration by parts. So take z to be first function and e to the power minus z to be second function. So what happen, it will be z, and so first z, and now do the integration of e to the power minus z, it will be minus e to the power minus z, right? So e to the power minus z, now you have to evaluate integral from 1 to m. Now minus integral 1 to m, the derivative of the first function means 1, and integral of this e to the power minus z, so it will be again minus of e to the power minus z, right? So that's why it becomes plus dz, right? Now for the first one you can put the limit, so it will become minus m e to the power minus m, and for 1 to m it will become, if you put 1 it will become minus plus e inverse, right? Oh sorry, if you have to change also the limit here. When you put ln x equals to z, so when x equals to 1 z will be 0, right? So sorry, here the limit will be from 0 to it will be ln of m, right? So this limit is here, it will be ln m, means when x equals to 1 z will become 0, right? And when x is m, z will become ln m. So it is ln m, and this will be 0 to ln m, 0 to ln m. Now if you put this, what you will get? You will get minus, if you put ln m you will get, it will be minus m, it will be plus of m ln m, right? Or 1 by m ln m, I think. We'll get 1 by m ln m, right? So e to the power minus ln m means, so it will be 1 by m, right? So this, so you will get here minus ln m by m, and if you put, it will be 0. And further now do the second integration. If you do again, it will be e to the power minus z. Now you have to evaluate from 0 to ln m, right? This, so limit m tends to infinity minus ln m by m, sorry, if you put here, it will be 1 by m minus 1 by m, and if you put 0, it will be plus 1, right? So what happen, if you take now m tends to infinity, growth of ln m is lesser than m, means this is the limit. If you take limit m tends to infinity ln m by m, this will goes to 0. You can do this by L'Hopital rule. Okay. By L'Hopital you can check. So, and 1 by m again goes to 0, so it's only remains, so this will be 0 minus 0 plus 1, mean it's 1, right? Both the first and second term goes to 0 as m tends to infinity, so 1 only remains. So the value of the integral, improper integral, is 1. So which option is correct? Option 2 is the right answer. Is this fine, the first one? Okay, so we have computed the value of the improper integral, integration 1 to infinity log ln x by x squared dx, it will be 1. Okay, so now move to the next question, question number 2. What it is saying, find the Cauchy principal value of this integral, and you have to show that this is the same of Cauchy principal value of this integral. You have to say it is true or false. So here there is a typo, I will say it later when I do it the second integral. So first do the first integral. So you have to compute this integral, integration minus infinity to infinity x square by 1 plus x square whole square dx. You have to find the principal value of this Cauchy principal value. We have written it like this, principal value of this integral. So how this is defined? Principal, because infinity here are treated as singularity, so you have to take the symmetric neighborhood, means minus, so limit m tends to infinity minus m to m. You have to take this to be same, means symmetric. Here minus m, here m, and x square by 1 plus x square whole square dx, right? So now you can break this integral into two parts, minus m to 0 and 0 to m. So what happen, it will be limit m tends to infinity, break this into two parts, minus m to 0 x square dx by 1 plus x square whole square plus 0 to m x square dx 1 plus x square, this. So we are breaking into two parts. Now you have to compute these two integral. So now you can do it easily, just make the change of variable. Here x goes to minus x in the first integral, so make change of variable, x goes to minus x. So what happen, it will be then limit m tends to infinity. So the integral limit will change. When x is minus m, it will become m, and when it is 0 it will become 0, and but then dx will it will be minus dx, right? So integral limit will be changed, so we get integral 0 to m, and x is, because x square is there, it will remain x square dx. Here also it will be 1 plus x square whole square, and the second is remaining same. In the first integral we have only make the change of variable in the first integral. This and remaining same. This second one it's same, x square dx by 1 plus x square whole square, right? So what happened? So this now it become 2 times, right? So what is the value of this? Okay, now you have to compute this integral m to infinity. It will become 2 times this integral, right? 0 to m x square dx by 1 plus x square whole square. Now how to do this? Okay. Now you can here do this, limit m tends to infinity. You can put here, just add and subtract 1 plus x square minus 1 plus x square, right? So what happened? It will be then, so if you add and subtract, the first one become dx by 1 plus x square, and subtract you have minus 1, then it will become integral 0 to m dx by 1 plus x square whole square. So you have add and subtract plus 1 minus 1, then it will become like this, right? So now you can do this first integral. So what is, now it will be, it is the integration of tan inverse x, right? So tan inverse x from 0 to m. And the next one, how to do this? 1 plus x square so you have to do this 1 plus x square okay. You can put x equals to what? If you put something, you have to put, right? If you put 1 plus x square equals to z, what happens then? 2x dx, it will be dz, right? So it will become z to the power minus half. Again, this will be messed up. No, wait, we do not need to compute the value, right? We have to only show the Cauchy principal value will be same, right? Okay, correct. So we do not need to compute the value. So you have to just show that these two integral are same, right? So no need to do this. There is no need to do this, right? So first one is become this one, right? And now evaluate the second integral. What is the second one? So this is the first one. And what is the second integration? 0 to infinity 2x square by 1 plus x square dx, right? So then now the second one is integration 0 to infinity 2x square dx by 1 plus x square whole square. So you have to find the principal value of this. Means what will be then the principal value? Again you have to write limit m tends to infinity is 0 to m 2x square dx by 1 plus x square whole square, right? So it will become 2 into limit m tends to infinity integral 0 to m x square dx by 1 plus x square whole square, right? So now you can view that these two integral become same. So right, this is the first one and this is the second one. So you get the principal value of these two integral is the same, right? So Cauchy principal value of these two integral are same. So you get the Cauchy principal value of these two integral same, right? So which option will be correct? It will be true, right? Is it fine? Okay. Yes. Okay. So now move to the next question. Third one, what is it? You have to find the integral 1 to infinity e to the power minus x square dx, right? So this is again an improper integral because right integral is a limit is 1 to infinity. So you have to find this integral e to the power. Oh no, not find the integral. You do not need to find the value of the integral. You have to only just say that it is converges or diverges. E to the power minus x square dx, right? So this is again improper. So how to write this? So you can write this as limit 1 to, so limit. Okay, first note one thing, that means you know you have done the comparison test in the class, right? So note e to the power minus x square is less than e to the power minus x, right? For all x greater than 1, right? At x equals to 1 it becomes same, and when x is greater than 1 it has a greater decay, right? E to the power minus x square, so it decays faster than the e to the power minus x. So if you draw the curves like this, so at x equals to 1 it will grows like this and it has a much higher decay. So this is e to the power minus x square and this is e to the power minus x. So this is always less than e to the power minus x for all x greater than equals to 1, right? So now by the comparison test, so you can write this, right? 1 to infinity e to the power minus x square dx is less than 1 to infinity e to the power minus x dx, right? So this is true. Now if you want to find that this integral is converges or diverges, if you show that the right hand this integral 1 to infinity e to the power minus x dx converges, then because both are positive function and this integral is less than this one, and if this is finite then the left one is also finite, means this one will be converges, right? So now we have to check this integral is converges or diverges. We will check. So let's check this one. Integral 1 to infinity e to the power minus x dx. So this is improper integral. You can write limit m tends to infinity 1 to m e to the power minus x dx, right? Okay. So now integrate it, because now this is a Riemann integration in the interval 1 to m. So it will be minus e to the power minus x, right? And the value is from 1 to m. Now if you put it, what you will get? Minus limit m tends to infinity e to the power minus m minus e inverse, right? Okay. And as limit n tends to infinity limit m tends to infinity, e to the power minus m, this will goes to 0, right? So the first one becomes 0, it will become a inverse, means this is finite, right? So we get, so integral 1 to infinity e to the power minus x dx equals to a inverse, this is finite. So by comparison test, this left integral is also finite, which imply integral 1 to infinity e to the power minus x square dx is also finite, means this integral converges. So which option is correct? First option is correct, that this integral converges. Is this fine?
Yes, sir.
Okay. So now move to the next one, fourth one. What it is saying, let f and g are two odd functions, then f compose g is also an odd function. You have to say it's true or false. So what are odd functions? Odd functions, what are this means, we call it odd function, sorry, write it. F is an odd function if you put f of minus x, it should be minus of fx, right, for all x in the domain of f, right? So you have to check this. So it's given that f and g are two odd functions, so here no, we have what we have, f of minus x equals to minus of fx and g of minus x equals to minus of gx for all x, right? It's given f and g are two odd functions. You have to check f compose g is also an odd function. So you have to check f compose g, right? So f compose g of minus x we will take. How f compose g is defined? F of g of minus x, right? Now use the property for this g. So what happen? It will be g of minus x will be minus of gx, right? Now again f is an odd function, so use the property for that f is odd, so minus will again come out, f of g of x. So what is this then? Minus of, this is again f compose g of x, right? So what we will get? F compose g of minus x is minus of f compose g of x. So this is true for all x, right? So what is this? So meaning that f compose g is in, or g is odd functions, implies f compose g is an odd function, right? So this is true, right? Is it fine?
Yes, sir.
Okay. So now move to the next one. Question number 5. It is saying that let f and g are continuous functions in 1 to infinity, and we given that f and g are continuous functions. Continuous function with what is given, both are positive functions, and fx is less than gx is given for all x greater than a, right? So this is given. Now you have to say that then integral a to infinity gx diverges if this integral a to infinity fx diverges. You have to say this is true or false. So you have done the comparison test for integral, right? So if this is true for all x belongs to a, x greater than a, then the integral what will be by comparison test? Integral a to infinity fx, it will be less than integral a to infinity gx, dx dx, right? Okay, now what is given? You have to, it's given that you have to say that integral this integral diverges if integral a to f fx ds is diverges. So it's given that the left hand side this integral diverges, means it's given that the value of this integral is infinity, right? And as the right hand side integral is, so left hand side is diverges, so by comparison test the right hand side integral will be again infinity, means so integral a to infinity gx dx diverges. Right. So the option is correct, right? It's true. Is this fine? This is simply the comparison test for the integral. If this, as this one diverges, because the right hand side is greater than this, so if this is infinity, then this must be infinity, right? It cannot be finite. If this is finite, then there will be contradiction. So the integral a to infinity gx ds also diverges, right? Okay. So now move to the next one. Question number 6. What you have to find? Integral e to infinity 1 by x ln x to the power alpha dx. You have to show when this is exist finitely, if for which values are alpha this will give the finite value, right? You have to check this. So again this is improper integral, so write the in terms of limit m tends to infinity e to m dx by x ln x to the power alpha, right? Now make the change of variable, put ln x equals to z, so it will become 1 by x dx will be dz, and if when x equals to e, z become it's 1, right? And when x equals to m, so z become ln m. So right, put it here, then limit m tends to infinity integral 1 to ln m 1 by x dx is dz by z to the power alpha, right? Now you can integrate this. So what will be the, if we do the integration, what we will get? Limit m tends to infinity, so this is basically z to the power minus alpha, right? So what is the integration? Z to the power minus alpha plus 1 by minus alpha plus 1, and limit 1 to m ln m, right? So now if you put, you will get limit m tends to infinity, so this one will be ln m to the power minus alpha plus 1 by minus alpha plus 1, and if you put 1, it will be 1 by minus alpha plus 1. So now you have to check what happen if m tends to infinity, but you need this integral should exist finitely, right? So when this will be finite, you know that log ln is increasing, right? Is increasing. So if m tends to infinity, ln m goes to infinity. So as m tends to infinity, ln m tends to infinity, right? So if alpha is, means if alpha is less than 1, so what happens? If alpha less than 1, then minus alpha plus then minus alpha plus 1, what happen? It will be minus alpha, it will be positive, right? It will be positive. It will be positive number. Then ln of m to the power minus alpha plus 1. So this will, so limit m tends to infinity. This will be infinite, right? So if alpha less than 1, then this ln will goes to infinite, right? So limit, the value cannot be finite. So alpha cannot be less than 1, right? And again, what happen if alpha is 1? If alpha is 1, what happen? So this will, then you cannot write this, right? If alpha is 1, then this is also infinite. And if alpha equals to 1, then minus alpha plus 1 will be 0. Then you cannot write this 1 by minus alpha plus 1, right? In the denominator, it will undefined. So also alpha cannot be 1, right? So these two possibility gone. So only possibility is alpha greater than 1. So what if alpha is greater than 1? So if alpha is greater than 1, then what happen? So then limit, it will become m tends to infinity ln m to the power minus alpha plus 1 by minus alpha plus 1 minus 1 by minus alpha plus 1. So if alpha is greater than 1 means minus alpha plus 1 is less than 0, right? So ln m to the power minus alpha plus 1 as limit m tends to infinity, it will goes to 0, right? Because this power is negative, so it is 1 by ln m type of, and if m tends to infinity, ln m is goes to infinity means 1 by infinity, it's 0. So then it will be 0 means you get the finite value, right? So it is 1 by alpha minus 1. So this is finite. So if alpha is greater than 1, then this exists finitely, right? So which option is correct? Option number 3, right? We have checked all the 3 options. So only if alpha greater than 1, then this exists finitely, this integral, right? Is this fine?
Yes, sir.
Okay. So let's move to the next one. Now what is this is question number 7. It's saying that you have to find the integral 0 to 3 dx by x minus 1, right? So note then here the both limits are finite, 0 and 3. But is this Riemann integration? It's not, right? Because 1 is lies this interval in 0 to 3, and at the point 1, as x tends to limit x tends to 1 by x minus 1, it become infinite, right? So this has singularity at the point 1, so this is improper integral, right? So to do this, you have to write it this epsilon 1 tends to 0 and epsilon 2 tends to 0 you have taken. So how do you do? So 0 to 1 minus epsilon 1, we have make it 1 minus epsilon here in this 0 to, so if you look, you can view this as, so this is 0 1, this is 2 3. So at the point 0 it will become minus 1 and 1. So if you from the left, so this will be minus infinity like this curve, and 1 positive it is become like this, and 3 it's become half, right? So this type of curve, this is the curve, right? So what we will do, 0 to 1 minus epsilon 1 you will take this limit from this to this, and 1 plus epsilon 2 you will take to 3. We have taken the limit epsilon 1 epsilon 2 because if you take the both the same epsilon, you will get the principal value. Okay, I will discuss it later. So this is dx by x minus 1 plus, you will write it as 1 plus epsilon 2 to 3 dx by x minus 1, right? So we have written in this, written like this. So this is the curve of 1 x minus 1. Okay, now you can do this integration, right? Because in the 0 to 1 minus epsilon, 1 by x minus 1 is bounded function. Now you can do the Riemann integration, and for this 1 plus epsilon 2 to 3, 1 by x minus 1 is again bounded. So you can do this. So limit epsilon 1 tends to 0, epsilon 2 tends to 0. So what will be the integration? So it is ln of log of mod of x minus 1, right? 0 to 1 minus epsilon 1 plus, do the second integration, it will be same again, log of mod x minus 1, the integral value is 1 plus epsilon 2 to 3, right? So then if you put this limit epsilon 1 tends to 0, epsilon 2 tends to 0, so if you put the first 1 minus epsilon 1, what you will get? Log of epsilon 1 minus log 1, if you put 0, it will be log 1, it's 0, right? And for the next limit, if you put 3, you will get log 2 minus, if you put 1 plus epsilon, we get log of epsilon 2, right? Now as limit epsilon 1 tends to 0, log epsilon 1 become minus infinity, right? And this will again be infinity. So this diverges, right? This diverges, this integral diverges, because this is not gives the finite value, right? As epsilon 1 tends to 0, log epsilon 1 goes to minus infinity, and as epsilon 2 goes to 0, log of epsilon 2 goes to minus infinity. So this integral, so what is the integral? 0 to 3 dx by x minus 1 diverges, right? So we get this integral diverges. Now if you want to compute the principal value, Cauchy principal value, then so this is extra I am saying. So in general this integral diverges. Now came to the Cauchy principal value. Cauchy principal value. So for Cauchy principal value, if you want to compute this integral 0 to infinity dx by x minus 1, then how you will break? So you will only take the symmetric interval, right? Only epsilon tends to 0, 0 to 1 minus epsilon dx by x minus 1 plus 1 plus epsilon to 3 dx by x minus 1, right? Now if you do the integration in this time, what you will get? Limit epsilon tends to 0, it will be again same log of mod of x minus 1, 0 to 1 minus epsilon plus log of x minus 1, 1 plus epsilon to 3, right? So now if you put this limit epsilon tends to 0, if you put 1 minus epsilon, what you will get? Log epsilon, and if you put 0, you will get log 1, it's 0. Now if you put 3 in this here, you will get log 2 minus, if you put 1 plus epsilon, you get log epsilon, right? Now you will see that these two cancel out, right? So now if you take epsilon tends to 0, it will, there is, because epsilon cancel out log epsilon, you will only give the log 2, right? So this, so we are computing here the principal value. So this gives the finite value, right? So for this integral, Cauchy principal value exists, right? Because we have taken the symmetric 1 minus epsilon and 1 plus epsilon. Epsilon are same. So so principal value exists. But if you have to check the only convergence and divergence, you cannot take this epsilon and epsilon to be same. It may be the different, right? Epsilon and epsilon 2. So if you take the different, then we have seen that this integral diverges, right? So for this integral, it has a principal value exists, but in general it diverges. Is this fine? Any doubt? Yes. So you have get this integral diverges, but Cauchy principal value exists, right? Is this fine?
Yes, sir.
Okay. So now move to the next one. Question number 8. You have to find the integration 6x plus 7 by x plus 2 whole square using the partial fraction. Okay. So what is the means you have to use the partial fraction means integral. What is this? Integral is integrand is this. Partial fraction means you have to write it in terms of like this. This is called a y because there is in denominator it's square terms. So you have to write like this: x plus 2 whole square plus b times x plus 2 by x plus 2 whole square. Means you have to write like this. This is called the partial fraction decomposition, right? So now you can find the value of a and b. So what is the right hand side? It is become a plus 2b plus bx, right, by x plus 2 whole square. So now if you compare with this, so bx and here 6x, right? So you get b equals to 6 and a plus 2b, comparing just this. Comparing we get a plus 2b is 7, right? So if you put b equals to 6, what you will get? A equals to 7 minus 12, it is minus 5, right? So we get the value of a and b. Now put here. So what we get? 6x plus 7 by x plus 2 whole square equals to minus 5 by x plus 2 whole square plus what is b is 6 x plus 2 by x plus 2 whole square. So by doing the partial fraction decomposition we get this. So this is the same as minus 5 by x plus 2 whole square plus 6 by x plus 2, right? So now you have to find the integration of this. So if you want to find the integration of this one, 6x plus 7 by x plus 2 whole square dx. So it is the same of doing the integration. This minus came out, it will be 5 dx by x plus 2 whole square plus 6 into integration dx by x plus 2, right? So we get this, right, using the partial fraction decomposition. Now you can integrate both these terms easily, right? So what will be the, so minus 5, so what will be the integration of this? It is means it is the x plus 2 minus 1 plus minus 1 by minus 1, right, plus 6 log of or ln mod of x plus 2 plus c, because this is a indefinite integral, so constant will be there, some constant. So what you will get? 5 by minus 2, am I doing it correct? Okay, right. So it will be 5 of x minus 1 x plus 2, sorry, 5 of x plus 2 whole inverse plus 6 ln of x plus 2 plus c. So we get this. So now check which option is correct. So option 1 is the correct, right? Because there is 6. So we get option 1 is the correct answer. 6 ln of x plus 2, 5 of x plus 2 whole inverse plus c. So option 1 is the correct one, right? Is this fine?
Yes, sir.
Okay. Now move to the question number 9. So what it is saying, you have to find the area of the region enclosed by the curve y equals to e to the power minus x and the positive x-axis. So draw this. So this right. So how y equals to e to the power minus x curve look like? So this is the e to the power minus x, and positive x-axis means this one. This one, right, from right to infinity, this side. So you have to find the region enclosed by this, means this curve y equals to e to the power minus x and positive x. This region you have to find, right? So means you have to basically how to find. So means you have to find the. So this is the area under the curve e to the power minus x, right? So if you integrate this curve from 0 to infinity, you will get this area, right? Because if you integrate any function, you will get the area under the curve, and this is exactly what we need, right? So you have to find the integration of this. So the required region is, it will be same as integration 0 to infinity e to the power minus x dx, right? Because if you integrate this function from 0 to infinity, it will give the area under this curve, right? So it is this region. Okay, so just integrate this. What you will get? You get minus e to the power minus x 0 to, means this is improper integral. You can do it like we have done, right? So how to do this? Limit m tends to infinity 0 to m e to the power minus x dx, right? So limit m tends to infinity to minus e to the power minus x from 0 to m. So now if you put limit m tends to infinity minus e to the power minus m plus 1, right? Because minus plus. Now if you make m tends to infinity, as you know, limit m tends to infinity e to the power minus m, this goes to 0, right? So you get 1, right? So we get this integral is 1, means the area of the region is 1, right? So which option is correct? Option 3. So the area of this region is 1, right? Is this fine? Okay. So move to the last question number 10. So you have to find the value of the integral minus infinity to infinity dx by 1 plus x square, right? So this is again improper integral. So write this like, so limit m1 tends to infinity, m2 tends to infinity, minus m2 to m1 dx by 1 plus x square, right? We have taken different, right, m1 m2, because we want to find the integral. If you say that you have to find the principal value, you can take the minus m to m, but in general you have to find the integral, then you have to take the two different, right? So now what happens? Limit m1 tends to infinity, m2 tends to infinity. So what is the integration dx by 1 plus x square? It is tan inverse x, right? Tan inverse x minus m2 to m1. Now put here. So what you will get? Limit m1 tends to infinity, m2 tends to infinity. So it will become tan inverse of m1 minus tan inverse of minus m2, right? This. now tan inverse minus will come out, means it will become limit m1 tends to infinity, m2 tends to infinity, tan inverse m1 plus tan inverse m2. Now if you take m1 tends to infinity, m2 tends to infinity, we know that limit x tends to infinity tan inverse x is pi by 2, right? This we know. So what you will get? You will get pi by 2. If you make tan inverse m1 tends to infinity, tan inverse m1, it will be pi by 2. And for tan inverse m2, as m2 tends to infinity, it will be again pi 2, right? So we get pi. So we get this integral exists and the value is pi. So if the integral exists, then the principal value will also give the same value. So means for the principal value we get also the pi. Means here we don't need. So the value of the integral is pi. Option 3 is the correct. So means for this integral you see that the here integral exists, and the if you check the principal value, it will give the same value. Means if the original integral exists, the principal value will be the same. But in general, if the integral may not exist, Cauchy principal value might exist, right? As we have seen the previous example, this one. Here integral does not exist, but the Cauchy principal value exists, right? Okay. So we have done the last one. Is this fine? Any doubt? Yes. Any doubt from this assignment?
No, sir.
Okay. So we have completed the assignment 6. Okay then. If there is no doubt, then bye. Okay. Let's end the meeting for today.